Okay, you guys, this is, what is this, chapter 12. So we're doing 12.7, conditional probability. This is our last lesson, yay. Now, to be honest, my brain is just not working. And for the conditional probability, I'm honestly just looking at the textbook. So if you are good with reading the textbook, this is the only reason why I'm doing the videos, because I don't know if somehow you guys sometimes when you read the textbook, it can be confusing. I'm honestly just going right from the textbook. So if you want to skim the textbook, and then, or you guys can watch, obviously, the video. Oh, floor is like sand. It's a pretty easy lesson. It's just a quick explanation. So by definition, the conditional probability is, as you can see, I don't even have any notes written up. Oh, because I'm so used to my Algebra 2 trig. That's right, Algebra 2 trig, you gotta write your own notes. I forgot, I usually give you guys notes. Oh well. Conditional probability is the probability of an, although it's gonna take me a little bit longer to do problems, oh well, event given. So probability of an event given that another, that's the big thing, another event has already occurred. So something else has occurred. So just so you guys realize, when you guys can see in the textbook, you're gonna see a lot of it written like this, P parentheses P/A. What that is read as the probability, so I'm not gonna write that P, well here. It's the probability that event B occurs given, I don't think I wrote that right, but there we go, given that event A has, it's kind of wordy, already occurred. Or in other words, they write this, or probability of B, right? We want of B given A. So it's after A that has occurred. So for example, again, I'm just grabbing these problems from the textbook. I just sometimes think reading a textbook is hard, so maybe if I explain it might be easier. Actually, before I do that, the example, I'm gonna write down the formula, you know how we've been doing formulas, and then I'll start it. So the conditional probability, and you'll be able to clearly recognize the conditional probability, we're gonna change it, well, I'll keep it, of B given A. So you want B after A happens, it looks like this. And again, you'll see B, whatever. It's gonna say the probability of, oh Lord, A and B all over the probability of, always the second one, A. Okay, so that's what you guys are gonna do. Just put the probability of like the second thing on the bottom. So here is your example. I'm gonna kind of like side, or not write full sentences, because I don't want to. So you have two die, or darn it, two dice. Okay, I wanna know the probability that one die is a 4, here you go, given that the sum of the two die is not, sum of two dice is 9. Okay, so if you kind of look, whatever this is the way I'm doing, whatever is following B given A, this here, whatever is gonna follow the given, that's the sample space of that, or the amount of outcomes, that's gonna go in the denominator. So what do we mean by that? Okay, so again, what you're doing is, let's just make this event A, since that's up there, and this is event B, B given A. So, okay, well, I don't know why I wrote P, well, whatever. So how many, let's do the bottom first. 9s are there. When you roll a die, you can get a 3, a 6, a 6, 3, a 4, 5, and a 5, 4. So that's it. You have 1, 2, 3, 4. This is what's going to be in our denominator. Okay, because that's all. You have to, it's a probability after A, right? So you have to first have this. So of those 4, how many times will you get a 5? Oh my God. Of those, 4 choices. How many times can you get a 4? 2. So 2 over 4 or 1/2 or 50%. That's it. It's kind of weird, I know, the way it's kind of worded and all that stuff. So there's your first one. We're just going to do a couple, like 3 examples. And then I think you guys would get it. And I would say definitely you can look at page 904 in our textbook. It has a lot of it. So let's do another one. I'm in a grocery store. Conditional probability and independent. So I'm just kind of looking in the textbook. Oh, we've done dependent or the multiplication. All right, so at a grocery store, we're going to say 32% bananas are ripe. Okay? Then 8% are bruised. And 3% are ripe and bruised. Banana is selected at random. So we got what is probability banana is ripe, oh, yikes, given it is bruised. Okay, so again, what you want, if you want to do for yourself, knowing what the formula kind of works with, given is what's going to come second. So this is my, oopsie, given your A, you want B. Okay, so first thing, what is, so we got the probability, we can just say B over A. So A goes on the bottom. So how many bananas are bruised? 8%, so about 0.08. Okay, now I want to know, so this one's a little bit different. Of the 8% that are bruised, I want to know how many of them are ripe. Well, you're going to use this number because you're looking for what is the probability the banana is ripe given it's bruised. These are just ripe. They might not be bruised, but you know that that definitely is, and that's where the end comes into play. That's your A and your B, so perfect example for it, which is probably why they did this example after they gave you that formula. Not like it matters. But anyway, so 03, put that in your calculator, whatever you want. You get 3 over 8 or 37.5. Now, watch what happens if I changed it. If I used the same thing from above, but now I said banana bruised, given it's ripe. So I just reversed it just to show you guys the difference. So given the ripe, so this is going to be my A. Whatever falls after given, I usually put A, and this is my B. Okay, so A goes in the denominator. So ripe, how many are ripe? 32%, the 0.32. Now I want the bruised and ripe. It's still going to be that 0.03. And you can get 3 over 32, which is the same, or about 9%. Oop. So hopefully that makes sense. I'll just do one more. Again, I'm just looking at the examples in the textbook. I don't really give you that many problems anyway. All right, so real quick, you have a fruit stand. 24% of the grape bags have red grapes. So you got 24% red grapes. We got 15% black grapes. And then we have 3% of the bags, so these are bags. 3% have both, red and black. So bags of grapes. Okay, so the first question I want to know, what's the probability so that the bag contains red grapes given it contains black. Okay, so here you go again. This is my given. Here's my A, here's my B. Okay, so the percent of black is 15, so 0.15. Red black, because you got to put them both, is 3%. So 0.03, 3 over 15, 1 over 5, or 20%. Okay, and then your last one, what happens if I said, given red grapes, what's the probability the bag contains black? So I did that on purpose. Whatever follows given has to be the A, and in this case, that's your B. So what percent is red? 24. Black and red, again, is at 3. So 1 over 8 or 12.5%. So that's a really easy lesson for you guys. Again, if you want to Google it, you can Google it. It was pretty short. That's from what I got from it anyway. Again, on page 904, there's a summary, which hopefully you guys are using your book. Page 904, there's a summary of all the probabilities. But obviously, you have to make sure you all know how to use them and what they mean. All right. Yay! Last lesson. Bye, guys.